In this video, we're going to look at finding the area of a regular polygon. So in the previous two videos, we looked at some of the terminology involved in the regular polygons, as well as an additional formula for finding the area of a triangle. So we're going to kind of pull both of those things into play here. So we have two basic options for finding the area of a regular polygon. If I know the apothem and the side measures, so I have to know the apothem, which is here, and then the side length, which is here. Or if I know the perimeter, then that would be using this formula as well. So remember, my perimeter is going to be S times N. S is going to be my side measure, and N is going to be my number of sides. So if I know both the apothem and the side measure or number of sides and or the perimeter, either way, then we can just find the area of the polygon by doing 1/2 times the apothem times the perimeter. If I don't know the apothem, but I know the radius, so remember the radius goes from the center to the vertex of the polygon, and I know the central angle, which I can always find out the central angle. Remember, the central angle is always 360 divided by the number of sides. Then we can use the formula from the area of a triangle if I know two sides and the included angle. And then we just multiply that by the number of triangles or the number of sides, because the number of triangles and the number of sides would be the same. So this part here is just using the formula that we had for area of a triangle when I have a side angle side situation. So 1/2 times the side measures multiplied together times the sine of the central angle. And then I would multiply that by the number of triangles that we could make here, which is going to be the same as the number of sides. So I can use either one of these formulas, just kind of depending upon what information I have. Sometimes I will only know the side measure or the perimeter, and then I can use sort of either one. I'm still going to have to do some work to find a missing measure, but I can do either one of these. So in our first example, we're going to find the area of the regular polygon. We're going to round our final answer to an integer and round any intermediate values to 2 decimal places. So that just means that any value that we have to calculate in the middle of our calculations, we're going to round to 2 decimal places. So in this case, I have the apothem, so I know my A value is 12.3, and I know that my side measure is 8 inches. So my apothem is 12.3, and my perimeter is going to be my side measure times my number of sides. So in this case, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So I have a decagon, so my perimeter is 8 times 10. So in this case, because I know the A and the P, I'm going to use the formula for the area of a polygon using the apothem measure. So 1/2 times A times P. So just plugging in the values that I have, I end up with 492. And then remember, in this case, we want to put the units on there, and it's going to be inches squared. All right, in this next example, we're going to again find the area of the regular polygon and round our final answer to an integer, intermediate values to 2 decimal places. So what we started with here was just simply the side measure. So I know that my side measure is 3 feet, and then I know that this is a hexagon because I have 6 sides. So I know N equals 6, and I know S equals 3. Again, that was all the information that I was given. So we have two choices here. We can either find the apothem measure, or we can find the radius measure. So I'm going to show both ways, and it would be completely up to you which method you would want to use. So in this case, I drew in the triangle here. So remember, the apothem is always perpendicular to the side, and it divides the side measure in half. So this part right here is just 1.5, half of 3. We want to find this measure here, this angle measure. So remember, this is going to be half of the central angle. So my central angle is this whole thing here, so that would be 360 divided by 6, but we only want this half of it, so I'm going to take half of that. So we end up with 30 degrees there. All right, so now in order to find A, we're going to use the tangent. So we have this angle measure here we know is 30 degrees, and then we have the opposite side, and we have the adjacent side. So I started with tangent of 30 as opposite over adjacent, plugging in the values that I know. 1.5 is my opposite, and then we're solving for A, which is the adjacent. So then we're going to end up with A is 1.5 over the tangent of 30, which gives me about 2.6. So now I know my apothem length is 2.6, and my perimeter is going to be S times N, which is 3 times 6. And so then I can plug into my formula. So I can plug into my formula, which is area equals 1/2 A times P. So the 1/2, I'm going to fill in my apothem measure and then my P, which is my side measure times the number of sides, and we end up with 23 feet squared. In the second method, we're going to work similarly, but instead of trying to find the length of the apothem, we're going to actually find the length of the radius. So using the same information that we had before, the central angle is 60 degrees and we want half of that is 30. This is perpendicular here. This side measure here is going to be half of the side length, so 1.5, and then we're trying to find the radius, which is r. So here I'm going to use the sine value because I have the opposite and the hypotenuse. So the sine of 30 is 1.5 over r. So solving for r, we're going to get 1.5 over the sine of 30, which gives me an r value of 3. Then I can use the other formula we had, which is the area value is the number of sides times the area formula for this triangle here, which would be 1/2 r squared times the sine of c. So plugging in all of my values and putting that into my calculator, I again get 23 feet. This next example, we have a similar question. It says we have a nonagon with side measures of 10 centimeters. So I just got a picture of a nonagon from the internet just to give us a visual here. And then all we know again is that this side measure is 10 centimeters. So we have the two methods again, just like we did before. So the first thing I'm going to think about is what is my central angle? So my central angle is going to be 360 divided by 9, which is going to give me 40 degrees. When I draw the triangle in, remember we're taking half of that central angle, so this angle is 20 degrees. It divides this side measure in half, so this little part of the triangle is 5, and then here we're going to find the apothem. So we're going to do tangent of 20 is 5 over a. So solving for a, we get 5 over the tangent of 20, which gives us about 13.74. So then plugging into my formula, area equals 1/2 of the apothem times the perimeter. So 1/2, my apothem measure is what we calculated, 13.74, and then my perimeter is the side measure of 10 times 9 sides, and we get about 618 centimeters squared. My alternate example over here is just like we did on the previous example. Instead of finding the apothem measure, we're going to find the radius measure. So instead of using tangent, I'm going to use sine because we have opposite and we have hypotenuse. So finding my radius value, we get about 14.62, and then plugging into the area formula, which is the number of sides times 1/2 times r squared, sine of my central angle. Remember here when we use the central angle, we have to use the whole central angle, which is 40 degrees, not the part that's here. So now we're going to do 9 times 1/2 times my 14.62 squared times the sine of 40, which gives me about 618 again. Rounding to the nearest integer, you should get the same answer here. If you round to like 2 decimal places, you may get slightly different answers here because you're rounding in your intermediate value. All right, number 8 is a similar example. We have a decagon here, so we have 10 sides, and the side measure is 6 centimeters. So first I looked at finding the central angle, which is 360 divided by 10, which is 36. So drawing in my triangle to solve for my apothem, or over here drawing in my triangle to solve for my radius. Either way, we're going to take this central angle and divide it in half, so 18 degrees. If I'm solving for the apothem, I'm going to do the tangent value. So tangent is opposite over adjacent, so 3 over a. If I'm doing the radius, I'm going to use the opposite and the hypotenuse, so the sine of 18 is 3 over r. So solving your trig, you're going to end up with your apothem or with your radius value, and then you're going to plug into your area formulas again, and both ways we get about 277 square centimeters. All right, here we're going to find the area of the regular polygon. So we have an octagon here inscribed in a circle, and they've given us the radius of the circle or the radius of the polygon, whichever way you want to think about it. So since we have the radius value already, then we're going to use the formula that uses the radius value. So then I have the radius value. The only other thing I need is the central angle and the number of sides. So I know the number of sides because I have an octagon, and then my central angle is just 360 divided by my number of sides, which is 45 degrees. So then plugging all my values in, we end up with about 706 square centimeters. So if I have this radius value, we don't have to do the trig step in there. We can just go ahead and use the formula. All right, and then this last question tells us we have a circle of radius 7 centimeters, and it's circumscribed about a regular pentagon. We want to find the area of that pentagon. So again, I just got this picture from the internet. I just did a search for pentagon inscribed in a circle. Once I had that, then remember we want to find the central angle. So the central angle is 360 divided by 5 because I have a pentagon, so 72 degrees. And then we have the radius measure. So again, I'm just going to plug into this formula, which uses the radius and the central angle. So we have 5 sides. My radius measure is 7, so 7 squared, and then sine of my central angle, which is 72 degrees. And then again, putting this into my calculator, we get about 117 centimeters squared.